Hello everyone and welcome to today's discussion. In this report, together with my partner, Ms. Lionel Padillo, we will discuss the lesson 9 about people and energy. And today, I will be responsible for discussing the fascinating world of renewable and non-renewable resources, two categories of resources that are essential to our daily lives. From powering our homes to fueling industries and transformations, these resources drive the world we live in. In the next few minutes, we'll look at what these resources are, some examples of which, and weigh their advantages and disadvantages. We'll also explore the environmental impact they have and discuss how we can reduce our ecological footprint. By the end of this report, you'll have a better understanding of how these resources shape our world and what we can do to ensure a sustainable future. Let's read our learning outcomes. Number 1, describe how different sources of energy are used to power everyday activities. And number 2, identify practical ways to conserve energy in daily routines to promote efficiency and reduce environmental impact. And now let's tackle first the natural resources. Natural resources include all Earth's organisms, air, water, soil, and materials like oil, coal, and ore that are removed from the ground. So these are classified into two types: the renewable resources and the non-renewable resources. And now let's discuss renewable resources. Renewable resources are any source that cycle or can be replaced within a human lifespan. So let's discuss the examples. Examples include letter A, food and fiber. These are renewable agricultural resources that can be harvested or raised for life. Agricultural products such as crops and plants that grow and can be harvested sustainably. Letter B, soil, a mixture of dirt and living organisms that supports plant growth. Letter C, wind. It is a clean and boundless energy source caused by uneven heating of the earth. Letter D, water, renewed constantly through the water cycle. And then letter E, sunlight. We know that it is an unlimited source of energy that supports all life on earth. Letter F, biomass fuels. These are organic materials such as wood and agricultural waste containing stored solar energy. So examples of biomass fuels are wood and agricultural products, solid waste, landfill gas and biogas, and also alcohol fuels. Letter G, geothermal energy. It is heat energy generated deep within the earth. So that is renewable resources. And now let's discuss non-renewable resources. Non-renewable resources exist in fixed amounts and take thousands of years to form. Once depleted, they cannot be replenished within a human lifespan. Examples are ores, fossil fuels, and nuclear energies. Let's start discussing the ores. Metallic ores include gold, silver, copper, aluminum, zinc, and etc. While non-metallic ores include salt, sand, gravel, clay, diamonds, gemstones, and etc. And the next example, fossil fuels. So in developing countries such as fossilized wood, charcoal, and peat. In developed countries, examples are coal, oil, and natural gas. So the coal types: peat, 50% carbon with water and contaminants; lignite, brown coal, 70% carbon; bituminous, soft coal, 85% carbon; and anthracite, hard coal, 90% carbon, which is considered as the cleanest burning but less abundant. And also petroleum and natural gas are the remains of mainly marine organisms, typically typically found in underground formations called troughs with natural gas trapped on top and oil on the bottom. And that's it for the non-renewable resources. And now let's tackle the advantages and disadvantages of renewable resources. Let's start with the advantages. Renewable energy technologies use resources straight from the environment to generate power. And with renewable energy technologies, you can produce energy locally. Renewable energy technologies require less overall maintenance than generators that use traditional fuel sources. So that's it for the advantages. And now let's move on to the disadvantages. While you can save money by using renewable energy, the technologies are typically more expensive upfront than traditional energy generators. Our resources are available around the world, but many of these resources aren't available 24/7 year-round. And also, there is a high need for energy storage, and lastly, geographic limitations exist. And now we will tackle the advantages and disadvantages of non-renewable resources. Let's start with the advantages. Non-renewable resources is easy to store. It is easily accessible. It is more compatible. It is affordable. It is present in fair quantity. It is easy to transport. It can be efficiently converted to the type of energy required. A power plant based on a non-renewable source of energy can be located anywhere as long as fuel is available. They are available throughout the year, unlike renewable resources. And lastly, they have high energy density. So those are the advantages of non-renewable resources. And now let's tackle the disadvantages. Non-renewable resources produces greenhouse gases. Its byproducts cause damage to the environment. And once exhausted, they are not easily replenished. Rising costs. Its residual products are generally non-biodegradable. Its products pose a potential threat to the human health, and non-renewable resources is responsible for acid rain. And that's it for the disadvantages of non-renewable resources. And now that we are done with the advantages and disadvantages of renewable resources and non-renewable resources, it is important to know the environmental issues. The different environmental issues of renewable resources and non-renewable resources are wind power, land use issues, and challenges to wildlife and habitat. Next is the land use and life cycle global warming emissions impacts of producing power from biomass. Also, the global dependence of transportation on oil. And lastly, health effects and risks to coal miners and those living in the vicinity of coal mines. So those are the different environmental issues. And now that we know the different environmental issues of renewable resources and non-renewable resources, it is important to know how to prevent these issues. So first is managing water. Proper management of water is achieved through water treatment both on small and large scale. This ensures there is sufficient water for human use. Water management can also be achieved by changing lifestyles, such as using only the amount of water required and not leaving taps running, which significantly helps conserve water. So we need to use water responsibly and avoid waste, and also implement water treatment at small and large scales. And the next prevention is reduce, recycle, and reuse. Recycling and reusing are better alternatives to disposing of items. For better management and efficient utilization of resources, reducing the amount of usage is also important. So, we need to cut down waste and reuse materials to manage resources efficiently. And the next prevention strategy is mass transport and hybrid vehicles. Encouraging individuals from using personal cars reduces the amount of fuel consumed globally. Buses and trains are better alternatives to personal vehicles as they have a lower personal to fuel ratio. So, mass transport and hybrid vehicles encourage public transportation and hybrid vehicles to reduce fuel consumption. And the last prevention is the laws and regulations or Republic Act number 9513, an act promoting the development and use of renewable and indigenous non-renewable energy resources. So encourage the development and utilization of renewable energy resources as tools to effectively prevent or reduce harmful emissions and thereby balance the goals of economic growth and development with the protection of health and the environment. So this law promotes the development, utilization, and commercialization of renewable energy resources. So that is all for the prevention. And that concludes my discussion. To wrap things up, we've learned that both renewable and non-renewable resources are vital to our society. Renewable resources like wind, solar, and water are natural, sustainable, and have far fewer environmental consequences, but they come with challenges like geographic limitations and storage needs. On the other hand, non-renewable resources such as fossil fuels and minerals, coals are abundant and convenient but are finite, and their use leads to serious environmental issues including pollution and greenhouse gas emissions. The key takeaway here is that we must approach resource use with a sense of responsibility by conserving water, recycling, using alternative transportations, and supporting laws like Republic Act number 9513, which promotes renewable energy. We can reduce the negative impact of these resources. As we move forward, let's make informed decisions that not only benefit us today but also protect the future for generations to come. Our actions matter and every step towards sustainability counts. Thank you so much for listening, and let's continue to make the world a better place and choice at a time. And that concludes my discussion. Let us welcome Ms. Lionel Padilla to continue our topic. Thank you so much.
Hello, everyone. This is Lionel Padillo, and I am going to talk about the energy. What is energy? Did you know that the word energy comes from the Greek word energos? It means active or in action. So this tells us that energy is all about making things happen. Whether it's moving something, lighting up on a room, or powering machines. So energy is the ability to cause change. So for example, when you kick a ball, your energy moves the ball. When you turn on the light, electrical energy makes the bulb glow. So energy is what allows things to move, change, or work in some way. So scientists measure energy in a unit called a joule, which we write as a J. For example, when you left an object, the amount of energy you use can be measured in joules. So it's like saying how much work was done. So think about riding a bike. Your legs provide the energy to move the pedals, which make the bike wheels turn. So the energy you use could be measured in joules. So, energy is powerful because it can cause changes in many different ways. So, let me give you some examples to show how energy works in real life. So, let's talk about energy changes temperature. So, when you heat water on a stove, the energy from the heat raises the temperature of the water, eventually making it boil. So this shows how energy can change temperature. So energy changes direction and speed. So imagine throwing a baseball. The energy from your arm changes the baseball's direction and speed. So the harder you throw, the faster it moves. So how about the energy produces light and sound? So think about a thunderstorm. The energy in the storm produces lightning, so which lights up the sky, and thunder, so which is so powerful and it can rattle windows. So this is a great example of energy causing dramatic changes. And these examples show that energy is everywhere, and it has the power to cause different types of changes, like heating water, moving objects, or lighting up the sky. And can you think of other examples where energy causes changes in your life? So energy is what helps us do work. It's the ability to make things happen. So like moving something or changing something around us. So for example, jogging. When you jog, your body uses energy to move your legs and make your body move forward. And this energy comes from the food you eat, which gives you the fuel needed for exercise. And next example, biking. So when you ride a bike, the energy from your muscles pushes the pedals, right? And making the bike move. So the harder you pedal, the more energy you use to move faster. And third, car. In a car, the energy from the fuel makes the engine work, so which turns the wheels and moves the car forward. The car needs energy to get you from one place to another. So dumbbell. When you lift the dumbbell, your muscles use energy to lift the weight, and this energy helps you work against gravity to raise the dumbbell. And how about lastly, the airplane? So an airplane uses energy from its engines to fly through the air. So the engines burn fuel to create the force needed to lift the airplane off the ground and move it forward. So energy is what makes things move or change. Whether you're jogging, biking, driving a car, lifting a dumbbell, or flying an airplane, energy is helping you do work and make things happen. Even when you're not doing anything, like when you're sleeping, your body is still using energy. Let me give you a cute example: a sleeping puppy. So even though the puppy is resting, it's still using energy. It has a stored energy on its body from the food it ate earlier, and this energy helps the puppy maintain its body functions like breathing, keeping its heart beating, and even growing while it sleeps. So one of the most important rules in science is the law of conservation of energy. So it says that energy cannot be created or destroyed. Instead, energy can only change from one form to another. So let's look at how energy transforms in different situations. So let's talk about chemical to mechanical energy in a car. So in a car, the fuel which stores chemical energy, what I said earlier, so it gets burned in the engine, and this chemical energy is transformed into mechanical energy, which makes the car move, right? And next, chemical to radiant energy in a fire. So when we burn wood or other fuels, the chemical energy in the fuel is transformed into radiant energy, which is light, and thermal energy, which is heat. That's why a fire gives off both light and warmth. And third, chemical to mechanical energy in a human body. So when we eat food, the body breaks down and the food into chemical energy. So this energy is then transformed into mechanical energy when we move or do physical activities like lifting something. So lastly, electrical to thermal energy in a heater. So like, let's give an example in a heater. So in an electrical heater, energy is converted into thermal energy, heat, to warm up a room, and this is a sample example of energy transformation. So remember, energy is power. Energy is never lost. It just changes for form from one kind of energy to another. So whether it's chemical energy in food or fuel, mechanical energy in motion, or electrical energy turning into heat, energy is always being transformed. Potential energy is the stored energy that has the potential to do work. It's the energy an object has because of its position or condition. For example, if you lift something off the ground, you give it potential energy because it can fall and do work when it does. So the formula for the potential energy is PE is equals to mgh. So where m is the mass of the object in kilograms. G is the gravitational pull of the Earth, which is 9.8 meters per second squared. Meters per second squared. This is the force that pulls things toward the ground. So H is the height or the distance the object can fall. So think of a rock as sitting at the top of a hill. The higher the rock is, the more H, which is the height. And the more massive the rock is, the more M, or the more mass. So the more potential energy it has. If the rock falls, that potential energy will be converted into kinetic energy as it moves. So potential energy is like a reserve of energy that's ready to do work. The higher something is, or the more massive it is the more potential energy it has. This energy can be released, like when you drop the rock down the hill. So when you stretch a rubber band, you're storing energy in it. So this is called elastic potential energy. So the more you stretch it, the more energy you store. When you let it go, the energy is released and the rubber band snaps back. So imagine water at the top of a waterfall. The water has potential energy because it's high up. So the higher the water is, the more energy it stores. So when the water falls, that stored energy turns into kinetic energy as it moves down. So for example, a yo-yo held in your hand also has a potential energy. So it stores energy because of its position. The higher you hold the yo-yo, the more energy it has. So when you let it go, that energy makes the yo-yo fall and spin. Kinetic energy is the energy an object has because of its motion. Whenever something moves, it has kinetic energy. The faster it moves, the more kinetic energy it has. So, the formula for kinetic energy is Ke is equals to 1 over 2 times m times v squared. So, where m is the mass of the object in kilograms, v is the velocity or speed of the object in meters per second. This velocity is squared, meaning we multiply the speed by itself. So think about a car driving down the road. The car has kinetic energy because it is moving. If the car goes faster, it has more kinetic energy. The heavier the car is, more m, or the more mass. And the faster it goes, the more velocity. And the more kinetic energy it has as well. So kinetic energy is the energy of motion. Everything that moves, from a car to a bouncing ball, has kinetic energy. The faster it moves and the heavier it is, the more energy it has as well. So imagine we have two rocks rolling down in a hillside. So both rocks are moving at the same speed. So let's think about which rock will have more kinetic energy and which one could cause more damage when they hit something at the bottom. So even though both rocks are moving at the same speed, the larger rock has more kinetic energy because it has more mass. In the formula for kinetic energy, Ke is equals to 1 over 2 times m times v squared. We can see that the mass of the object plays an important role. So the larger rock with more mass will have more kinetic energy. So since the larger rock has more kinetic energy, it will also cause more damage if it hits something at the bottom of the hill. So this is because it carries more energy due to its size, and that energy will transfer when it collides with an object. So not all moving objects have the same amount of kinetic energy. So the speed and mass of the object both affect how much energy it has. In this case, the larger rock causes more damage because it has more mass and therefore more kinetic energy. So when you shoot rubber band, you give it kinetic energy. As you release it, the rubber band starts moving. The faster it moves, the more kinetic energy it has, and the energy comes from you pulling it back and releasing it, and it causing it to speed up. So water falling over a waterfall also has kinetic energy. As the water moves downward, it speeds up, gaining more kinetic energy. The faster the water falls, the more kinetic energy it has. And this energy is what makes the water crush at the bottom. So when you play with a yo-yo, it has kinetic energy when it moves up and down. The yo-yo speeds up when it goes down, and the faster it moves, the more kinetic energy it has. So the energy is transferred from you to the yo-yo when you give it a flick. Imagine water at the top of the waterfall. The water has potential energy because it's high up. As the water falls, that potential energy turns into kinetic energy. The faster the water falls, the more kinetic energy it gains, like what I said before. So as the water moves downward, the stored energy from being high up is transformed into energy of motion. So for example, a roller coaster is another great example. So when the coaster car is pulled to the top of being the first big hill, it has a lot of potential energy because it's high up. As the car goes down the hill, that potential energy turns into kinetic energy. So the faster the roller coaster car goes, the more kinetic energy it has. So, and that's what makes the ride so thrilling. So both waterfalls and roller coasters show how potential energy is converted into kinetic energy. So when something is high up or has stored energy, like the water or the roller coaster car, that energy transformed into motion as it falls or moves down, gaining speed along the way. So when you are standing still, your body has potential energy. So this is because your body is in a stable position and is it moving. So if you're standing on a higher ground on the edge of a platform, you have even more potential energy due to your height. So when you start running, the potential energy in your body is converted into kinetic energy. As your body moves, that stored energy turns into motion. So the faster you run, the more kinetic energy you have because you're in motion. So when you're standing still, you have potential energy. Once you start moving, that potential energy changes into kinetic energy. So this process happens every time something goes from rest to motion. Let's talk about mechanical energy. So it is the total energy of an object has due to its motion and its position. So it is made up of two types of energy. Kinetic energy, which is energy due to motion, and potential energy, PE, which is energy due to the object's position or state. So the total mechanical energy, TME, total mechanical energy of an object is the sum of its kinetic energy and its potential energy. So we can write it like this. So TME is equals to PE, potential energy, plus KE, the kinetic energy. What is the TME? The TME again, that's the total mechanical energy. So this means that the total mechanical energy of an object depends on both how fast it is moving and where it is positioned. So let's take a rock rolling down a hill. So at the top, it is a potential energy because it's high up. As it rolls down, the potential energy is converted into kinetic energy because it's moving. So the total mechanical energy of the rock is combination of both these energies. So mechanical energy is the total energy of an object when you combine its potential energy due to position and its kinetic energy due to motion. So these two types of energy together give you the object's total mechanical energy. Okay. So let's check our understanding. So I have an example here. So a cart is loaded with a brick and pulled at constant speed along an inclined plane to the height of a set top. If the mass of the loaded cart is 3.0 kilogram and the height of the seat top is 0.45 meters, then what is the potential energy of the loaded cart and at the height of the seat top? So to calculate the potential energy of the loaded cart at the height of the seat top, we can use the formula for potential energy. So the formula is PE, potential energy, is equals to mgh. So where m is the mass of the cart at 3.0 kilogram, g is the acceleration due to the gravity, approximately 9.8 meter per second. H is the height, that's 0.45 meters. Now substitute the values into the formula. So PE is equals to 3.0 kilogram times 9.8 meter per second times 0.45 meters. So let's calculate that. The potential energy of the loaded cart at the height of the seat top is 13.23 joules. So let's move. So let's talk about another topic. Still the same with the energy, but different. Like another topic of energy. Like for example, the microwave oven energy transformation. So when you use a microwave oven, elastic energy is first supplied to the microwave. So this electric energy is then converted into radiant energy. So which is the form of energy in the microwaves, waves. These waves heat the popcorn kernels, causing them to pop. So as the kernels heat up, the radiant energy is then transformed into thermal energy, which is what cooks and pops the popcorn. So next, the television energy transformation. So a television works in a similar way. Electric energy is supplied to the TV. So this electric energy is converted into sound energy to produce audio, the sound you hear from the speakers, and radiant energy to create the visuals you see on the screen. So the electric energy is transformed into both forms of energy to make the TV work. And the third one, energy transformation process. So the process of changing one form of energy into another is called energy transformation. In both examples, the microwave and the television, the electric energy is converted into other forms. So like radiant energy and sound energy to perform a useful task like heating food and providing entertainment. So, when you throw a ball upward, it starts with kinetic energy because it's moving. But as the ball rises, it slows down due to gravity. So during this upward motion, the kinetic energy is gradually transformed into potential energy because the ball is getting higher. So the higher it goes, the more potential energy it has. So and the less kinetic energy it has as well. So once the ball reaches the highest point and starts to fall, the potential energy that the ball had at the top is now converted back into kinetic energy. So as the ball falls, it speeds up and its kinetic energy increases while its potential energy decreases. So throughout the ball's motion, the energy keeps transforming between kinetic energy due to motion and potential energy due to height. So this continuous process happens every time the ball moves upward and downward. So showing how energy can change forms back and forth. Let's talk about the maximum kinetic energy. So when the ball leaves the hand. So when the girl, let's have an example. When the girl throws the ball, it leaves her hand at its highest speed. So at this moment, the ball has the greatest kinetic energy because it's moving the fastest. The energy is entirely in the form of motion at this point. Next, energy transformation as the ball rises. So let's have an example. So as the ball rises, it slows down due to the gravity. So the kinetic energy of the ball starts to decrease because the speed is lowering. At the same time, the ball gains potential energy because it's getting higher. So the energy transforms from kinetic to potential as the ball rises. So the third one, highest point. So at the peak of the throw. So at the highest point of the ball's path, its gravitational potential energy is at its maximum because it's the highest point in the air. However, its kinetic energy as its minimum, almost as zero, because the ball is momentarily not moving before it starts to fall back down. Let's talk about the maximum kinetic energy. So when the ball leaves the hand. So when the girl, let's have an example. When the girl throws the ball, it leaves her hand at its highest speed. So at this moment, the ball has the greatest kinetic energy because it's moving the fastest. The energy is entirely in the form of motion at this point. Next, energy transformation as the ball rises. So let's have an example. So as the ball rises, it slows down due to the gravity. So the kinetic energy of the ball starts to decrease because the speed is lowering. At the same time, the ball gains potential energy because it's getting higher. So the energy transforms from kinetic to potential as the ball rises. So the third one, highest point. So at the peak of the throw. So at the highest point of the ball's path, its gravitational potential energy is at its maximum because it's the highest point in the air. However, its kinetic energy as its minimum, almost as zero, because the ball is momentarily not moving before it starts to fall back down. The law, so let's talk about the law of conservation of energy, states that energy can change forms or move between different regions, but it can never be created or destroyed. So this means that the total amount of energy in a system remains constant. So for example, energy can transform from one type to another, like potential energy turning into kinetic energy, but the total energy in the system doesn't change. So the total energy in the universe remains constant, no matter how many times energy changes form or gets transferred. So for instance, when you push a ball up a hill, the energy you put into it may convert from your muscles, chemical energy to the ball's potential energy. So, but the total amount of energy in the system doesn't change. So examples of energy transformations include converting potential energy into kinetic energy, like when a ball falls and speeds up, or transferring energy between objects or regions, such as when a hot object transfers heat to a colder one. So this process shows how energy moves and changes, but the total energy remains the same. So when a bicycle slows down or stops, the mechanical energy or the energy due to the bike's motion is converted into thermal energy. So this happens when the brake pads press against the wheels. So the friction between the brake pads and the wheels generates heat, so which is the thermal energy. As the brake pads rub against the wheels, the generated thermal energy is spread around. So the brake pads, the wheels, and the surrounding air all get warmer or init because nag-absorb man siya og heat. So the energy doesn't disappear. So it just moves to different parts of the system na to. Or parts of the system sa bike or sa brake or sa wheels. So even though the mechanical energy of the bicycle changes into thermal energy, the total amount of energy in the system remains parehas ra gyapon. So this follows the law of conservation of energy. So which says that energy cannot be created or destroyed or magba. So it only transforms from one form to another. So let's talk about friction and transformation. So friction is the force that resists the sliding or motion of two surfaces in contact with each other. So for example, when you use the brakes on a bicycle or kanang brake, the friction occurs between the brake pads and the wheels. what mo yun ka nang nagka-break kay natoy brake pad then mahuno or ma-pause kay mao mo gito siya nag-stop. So this friction converts the mechanical energy, the energy from the bicycle's motion into thermal energy or heat. So the energy doesn't disappear, naragapon, but changes from one form or motion to another heat. Mo to ang heat, di ba? So causing the brake pads and wheels to warm up. So let's talk about the reducing friction. So unsa ang pag-reduce of friction? So lubricants like oil are often applied to moving parts. So for example, if you apply katong oil sa imong bicycle kanang chain, it helps the chain move more smoothly. So this reduces the amount of friction because siya pulabig kanang kayo kanang friction or kanang grabe ang paggasgas ganun or between the chain and the gear. So by minimizing friction, mechanical energy is better conserved and less energy is lost as heat. So ang resulta kay it's easier to pedal because it's easier na sa pedal kay it's less energy and is wasted and more energy is used for kanang actual motion. So using energy. So energy changes from during use. So like when a lamp is turned on, the lamp takes an electric energy, right? So from the power source and converts into radiant energy like suga or light na mo brighten sa room. So however, not all the energy is turned into light. So some is nag-transform into thermal energy or heat. So which warms the light bulb. So when you use energy, it often changes into more than one form like light and heat in the case of the lamp. So man kabantay tanong kapanitan mag-inis tag suga, init ang suga. So using thermal energy. So thermal energy is energy that comes from itong heat. So it can be used in many ways. So for example, on a gas stove. So thermal energy from burning gas is used to luto o pagkaon. So space heaters use thermal energy to warm rooms, and jet engines use it to power airplanes. So in all of these examples, thermal energy comes from a variety of sources, so such as burning, fuel, or electricity. So and it's used to perform useful tasks like heating, luto, or powering machines. So, gamit og chemical energy or using chemical energy. Chemical energy is stored in substances and can be released during chemical reactions. So, for example, the plants captured the sun's radiant energy through photosynthesis. So, converting into stored chemical energy in the form of pagkaon or food. So this food then provides energy for other organisms like animals to eat. In the human body, we transfer chemical energy from food into kinetic energy. So for movement like walking or running, and thermal energy to keep our body warm. So using radiant energy. So radiant energy is energy that travels in the form of waves. So like light or microwaves. For example, cellphone work. So by transforming sound energy ang atong tingog into electric energy or electric signals, and then into radiant energy microwaves to send signals other phones when receiving a call. So the process works is reverse. So the phone converts radiant energy back to electric energy. So which is then turned into sound energy so you can hear the other person. So using electric energy. So electric energy powers many devices around us. For example, handheld games get their power from batteries, so which store chemical energy, right? So the battery transforms this chemical energy into electric energy to run the game. So on the other hand, kanang mga hair dryer kanang gikan sa electric energy from power plants. So in both cases, electric energy is the main source that drives these devices. So, what is waste energy? So, during energy transformations, not all energy is used efficiently. So, some energy is lost as waste energy. Yan naman. Okay, it is often in the form of thermal energy or init or heat. So, for example, kanang light bulbs are on, so they convert electric energy into light, diba, ang siga. But some of it turns into init or heat. So, it kanang balit ko ighikap nimo sa suga, init. So similarly, cars, it releases heat into the air. So while converting fuel into motion, this heat is an example of waste energy because it doesn't contribute to the device's intended function. And that would be all for my topic. And thank you so much for listening. And I hope you learned a lot from us. So this is Lionel Padillo, and to my partner, Judy and Jandog. Let's save energy together and protect our Earth.